8.5, modeling data with sinusoidal functions. So this is the exact same thing as we did before, but instead of using linreg or, quadreg, we're going to be using sinreg. Now, don't think of it as, or sinreg. We're thinking of it in terms of sinusoidal functions, not necessarily just sine. That's what we're talking about. Now, in terms of our actual regression formula, it is always going to be in sine. But remember, I just don't want you guys to forget the fact that we still have cos as well as a potential sinusoidal function. So this one right here is a bit of a beast. So what I did was I put all of this data into my calculator and I literally checked it. So all we're going to be doing is going through the motions of how to punch in the problem. What I would do at this point is I would pause it and I would make sure that all of the day numbers, okay, these two columns here are in your L1 and these guys are in your L2. So why don't you go right now, pause, and fill up all your calculator with those values so that you can follow along with me. Okay, so we're back. Let's now go into our calculator. First of all, though, let's read the question. Celeste lives in Red Deer, Alberta. The predicted hours of daylight for 2 consecutive years are shown in the tables below. In the second year, the spring equinox will occur on March 20th, and the fall equinox will occur on September 23rd. Compare the hours of daylight for these 2 days. So what I want to do right now is go into my graphing calculator and I want to do a few things. So I'm going to go into my my lists here, so you'll notice that I have all of my values, okay, all of my L1 and L2. So let's change our window settings so that we're not like, oh my goodness, where did all the data go? First things first, let's turn our plots on. So I'm going to go second Y. Oh, I'm going to quit here first. Oh, okay. There we go. Second Y. And I'm going to hit enter. I'm going to go enter and I'm going to turn the plot on. Enter. Great. So that when I go into my window settings, so I'm going to go window, I'm going to say, okay, my X will go from 0 to the largest value is 731. I'm just going to go to 800. So 0 to 800. My smallest value here, it doesn't go less than 0, so I can put my Y value as 0. And my Y max as, let's see here. If I say 20, we're going to cover all the bases, so 20. So when I graph it, I'm noticing, oh hey, here we have this function here. Or we have these data points that fall really nicely into a sinusoidal function. Now what we're going to do is we're going to get that equation. So I'm going to go stat, calc, and I'm going to scroll down to sinreg. And as per usual, second L1, comma, second L2, comma, vars, so this guy right here, vars, y vars, enter. So that means that the equation is naturally going to go into the y1, enter, and enter one more time. Takes a little while. There we go. So when I write down my equation, now I'm not going to write down y equals a times sine of bx plus c plus d. Okay, that's not what we're going to say. And then where a equals, we're going to say y equals 4.3. Let's see, 4.382. Then sine, open bracket, sine of bx, so 0.071 x. Oh, sorry, 0.17, my bad. 0.17x plus c, which is negative 1.378, but I'm not going to say plus, I'm going to say minus 1.378, close bracket. And then we're saying plus D, but D is 12.264. Plus 12.264. You're noticing that this equation right here is a little bit different because in the equation that we did in 8.4, we said that the B was factored out in front. That's just two different versions of the sign function that you're just going to have to navigate between. So I have my equation right here, and if I were to bring up the graph, I would go into my graph and I'd say, oh, hold on. Let's think about this. If I get a line here and it isn't quite looking the way that I want it to, what I'm going to go is I'm going to go into mode, and then see how I have it in degrees? I'm going to put it into radians. Let's see what happens then. Hey, that's great. So unless the question specifically says degrees, make sure that your calculator is in radians. So great, I have this sinusoidal function, really good. So let's look at the question again. It says right here, in the second year. Okay, so we're not talking about this March 1st, but we're talking about the second one, this guy right here. The spring equinox will occur on March 20th, and the fall equinox will happen on September 23rd. Okay, compare the hours of daylight. Okay, so the day number is our L1. That is our independent. And the length of day is our L2, which is our dependent. So compare the hours of daylight of these 2 days. So given a specific date, so given your independent, figure out what the dependent value is. So we're given independent, and we need dependent. So when we come across this situation, we're just going to use the value. So second trace value. But here's the tricky thing with this question. We have to do some fancy figuring to figure out what the actual dates are. So we say March 1st is day 425. If I wanted to find March 2nd, I would have to add 1. Okay, so March 1st is the 425th day of this 2-year span. So that means that March 2nd, you would add 1, even though it's a 2. Okay, so when we're looking for March 20th, we're not going to add 20 to this number here. We're going to add 19. So for March 20th, we're going to say 425 plus 19, which is going to be 444. Woohoo, that's nice. And September 23rd. September 23rd is going to be 609 plus 22. So that becomes 609, 619, 629 plus 2 is going to be 631. Fabulous. So we want to find out when x equals 444, what does y equal? And for this one, we want to say when x equals 631, y equals what? So let's delve into our graph here. I'm going to go second trace value, which is nice because that's the easier one. So I'm going to first find out 444, hit enter. So when it equals 440, when x equals 444, when the day is 444, we have 12.097. 12.097 days of sunlight. Now, when we go into second trace value 631, we have 12.1296, so that becomes 12.130. And that makes sense. Now, the shortest day of the year is the winter solstice. The longest day of the year is the summer solstice. And these spring and fall equinox should kind of be around the same. And they are. So in March, the spring equinox, it's 12.97, and it's almost half of the day. Okay, that's pretty cool too. And in September, the fall equinox, it's 12.130.